Hello everyone, welcome back to another iBuddy Mathematics video. Today we're going to be going over the primary trig ratios. For instance, looking at the triangle here, how can we find a side length being x when we cannot physically measure it? Trigonometry is something which allows us to use the relationships between angles and sides in right angle triangles to solve these problems. So today we'll learn the three primary trig ratios, sine, cosine, and tangent, and how to use them to solve for missing angles and sides, such as x right here. Now, let's backtrack to here. We need to understand what even is a right angle triangle. Essentially, a right angle triangle is a triangle which has one 90-degree angle, such as that, and two smaller angles, like that, and three sides, being the hypotenuse, adjacent, and opposite. So, a few characteristics about all of these. The hypotenuse is always opposite to the 90-degree angle. It is always going to be the opposite, and it's always the longest side. You have to remember this. The hypotenuse is basically, from Pythagorean theorem, c squared, while the others are a and b. Moving on, the opposite is pretty clear. It's opposite to the angle of measurement, such as here we have theta up here, so opposite would be down here. And adjacent is a side beside the angle that you're looking at. And it's not the hypotenuse. So essentially, if you find hypotenuse and opposite, you already know which side is the adjacent. Important, the opposite and adjacent sides can change depending on which angle you're using. As we can see in this representation, as over here, opposite is there and adjacent here, but now here they're flipped since the angle has changed positions. Now we're going to go into explain how can we use SOH. Sorry, not SOH yet, sine, cosine, and tangent. Well, you already heard it there, SOH. Essentially, sine times the angle is basically opposite over the hypotenuse. That's the equation. SOH, specifically in this instance, is an easier way to remember what is the sine ratio. Since S stands for sine, O stands for opposite, and H stands for hypotenuse. Moving on to cos, which is Ka, is since cos equals adjacent over hypotenuse, and tan, TOA, is the opposite over the adjacent. So remember SOH. For instance, in this case, if we wanted to find out the hypotenuse and we had these two sides, we could use SO meaning sine, or we could use cos Ka, since we have the adjacent. But we couldn't use tangent since tangent never uses the value for hypotenuse. You don't memorize three formulas separately. In this case, SOH tells you which sides are involved for which ratio. Moving on, let's state the given trig ratios for this triangle. Just to make it easier, this is angle A, this is angle C, and this is angle B, which is the 90-degree angle. Now, you can try this on your own, but we're going to get straight into it right here. So, sine is opposite over hypotenuse. So what is opposite of, this is the opposite, 4, and hypotenuse is 5. So equals 4 over 5. Cos would be 3 over 5. And tan would be 4 over 3. Now for C, sine would be 3 over 5. Cos would be 4 over 5. And 10 would be 3 over 4. You can essentially see that Sine and cosine flipped when we changed the location of the angle, and tan just the values flipped. So let's just skip that. Let's go to here. What if you get given the angle, but you need to find the side length? In this case, this would be the triangle. This, let's say that's a 70-degree angle. We know that the hypotenuse is 15. Since this is adjacent, that is hypotenuse. And then this would be x. So now, in this case, we would want to solve for the x value. So we would get cos 70 times 15 equals x, since we're using algebra. And get out your calculators. I forgot to mention, I'm not sure, but your calculators, you need to have a calculator with a fraction key, sine, cos, and tan, and also make sure that it's in degrees mode and not radians. Radians is for higher level math. So now we can do cos 70 times 15, and x equals 5.1. There will be more numbers, but if most questions like this one are asking for 2, so you'll just put 5.13. We could try this. We could try this other one right here, which is tan 35. This one is. This angle is 35. 17x, so we will move this around. X equals 17 over tan 35. X equals 24.28. So that's essentially how you use sine, cos, and tan equation. And here's just simple steps for this. First, name the sides. Which one? For example, here, if this is the angle, this is opposite, hypotenuse, adjacent. Choose the appropriate ratio. Like for example, in this, we need to find the opposite, but we have the hypotenuse. So we would of course use sine. Since it's opposite over hypotenuse, would get sine 37 equals x over 11. X equals 11. Excuse my writing. Let's just solve that quickly on our calculator. That is x equals 6.6199. You can just say 6.62. Yep. And you solve for x. Now, another way to use this is to solve for the missing angle in this. It's a similar thing. Name the sides, choose your appropriate ratio, write the angle, convert the fraction to decimal, find the angle using the inverse ratio. For example, let's try it right here. Here we have opposite, adjacent, but we don't have the hypotenuse. So normally we will just use tan or opposite over. Yep. So now we have tan theta equals 35 over 45. We will have to do tan inverse. So theta equals tan negative 1 of, I'll just simplify, but you don't have to. This is 7 over 9. Just making sure. So tan inverse of 7 over 9 that is theta equals 37.8749. But in this case, most angles are required to be rounded to the nearest decimal, nearest whole number, sorry. So theta would be 38 degrees. And essentially, that's how you do it. So now that we know all of that, this initial question's quite easy. We have the adjacent, need to find the hypotenuse. Casually, we'll use cos. So cos 37 equals 8 over x. X equals 8 over cos 37. I'm skipping steps here, but you can essentially find out how to do such. How to move it around to get such answers, and then you'll get x equals 10.02. That's essentially how you solve using primary trig ratios. They're pretty simple. They're very applicable in the real world. And yeah. Common mistakes would be using the wrong ratio in certain circumstances. For example, if the angle was moved, let's say here, and you did the same ratio, using cosine, that would be wrong. You would have to use sine instead. And essentially, yeah. Once you can identify the sides of a right triangle, trigonometry becomes a simple relationship between the three ratios. It's essentially very easy since you just have to choose the ratio, know what values you're using, and just plug it into the calculator. Just be aware that in certain higher level questions, which could be on your tests, they could ask for like how many meters away is a certain place to another place, and in that case you could have to change units from like kilometers to meters to match up. But that is not really related to trig ratios. That's just what type of teacher you have. But essentially, trig ratios are a very easy concept of mathematics, but they're essential to all years of math, IB or not. Thank you for watching another iBuddy video.